Dear students, in this video I am going to explain about interference and what are the conditions to get the interference. So what is that interference? Actually, in this series of videos we are discussing about the light waves, that is wave nature of the light. So the important characteristics of the light wave is that is its ability. Okay, the light wave is having the ability to interfere with one another. Okay, so two or more waves will interfere with one another under certain conditions. Okay, under certain circumstances. So this part only we are going to discuss in this video, right? So the light wave is having the ability to interfere with one another under certain circumstances. Actually, before going to understanding this interference, let me give some examples. Generally, most of us observe some type of optical illusion every day, but we do not realize what occurring to produce this phenomenon. Okay, so let me give few examples so that you can understand. One is oil floating on the water surface. Oil floating on water surface, first example. And the second one is colors over the bubble, soap bubble, over the soap bubble. Okay, so these two examples I have taken to explain this interference. During the rainy season, we can observe this oil which float on the water surface. So for example, the oil is spreading like that, means over this the sunlight will fall so that it will produce the colors. Okay, it will produce the colors over the water surface. The same thing in the soap bubble also, on the surface of the soap bubble. Okay, the light will be incident on it so that we can observe different colors over the soap bubble. So who is responsible for the production of colors, okay, or formation of the colors over the surface? That means this film is called thin film. That is how much thin as possible it will spread over the either water surface or a soap bubble, right? So this is what that means the thickness of the film will be almost around few microns thickness. Okay, few micron, 10 power minus 6, few microns thickness. Okay, that much small it will be. So the light will be reflected by top as well as bottom of this soap bubble. So due to the interference of these two waves, it produces the colors. Okay, so these are some examples I said. So now how to understand the interference? Actually, if you see in physics, the definition of interference is the superposition of waves. Superposition of waves. So in the previous video, we have discussed about the superposition. So before watching this video, please watch superposition principle so that you can understand better, right? So now what will happen when the superposition takes place? The amplitude of the resultant wave, okay, the amplitude of resultant wave will be changed. So it may be increased or it may be decreased. Okay, so what is happening here? Light is modified. Okay, modification of light takes place when two or more light waves interfere with each other. So light of modified intensity or modified amplitude. Okay, so that we can say either increase or decrease in the amplitude of the resultant wave. When superposition takes place or interference takes place, the amplitude of the resultant wave will be modified. It may be increased or it may be decreased. So this is what the definition. When two waves from the sources superimposes, when two waves from the sources superimposes on each other, then the resultant amplitude in the region of superposition, in the region of superposition is different than the amplitude of individual waves. Okay, so this is the definition for interference. Actually, here I mentioned only two waves. Here we can mention two or more waves. Okay, two or more waves or multiple waves, right? So two sources, for example, S1, this is one source and this is another source, right? So the two waves are coming from the two sources. Two sources. At this point, both are interfering with each other. So this region is called region of superposition. Both are going to superimpose at this point. That's what it is called, superposition. Region of superposition. At this point, the amplitude, okay, the amplitude will be changed. So the amplitude will be different than the individual amplitude. For example, here the amplitude is 2 centimeter and here the amplitude is 3 centimeter. The resultant will be different. Maybe it will be added together, depends on the phase difference. Okay, so here we can write it as, it may be, the answer may be 5 centimeter or it may be the 1 centimeter. Okay, it may be added together or it may be subtracted together, depends upon the phase difference, but it will be different. It is not 2 or 3, it is also not equal to 2 or 3. So it will be different than the amplitude of individual waves. So that is called interference. Now once again you read, when two or more waves from the sources superimposes on each other, then the resultant amplitude in the region of superposition is different than the amplitude of individual waves. So this is what we have to understand. So what is that meaning here? The light energy is modified. It will be increased or decreased. Okay, so that change in amplitude takes place. What is taking place? Change in amplitude takes place. It may be maximum or it may be minimum. It will be changing. Okay, so that is what we have to understand. So the light energy is modified, or in terms of amplitude, how can we say the amplitude is changed? Okay, so this is the definition for interference. So next we are going to discuss about what is the conditions to get the interference. So what are the conditions to get sustained interference? So we are going to discuss three conditions one by one. Let us see. The first condition is, already I said, to make interference we need minimum two or more waves. Two or more waves. These two or more waves should be coherent in nature. Coherent in nature. The two waves should be coherent in nature. What is meant by coherent? The two waves should have the same frequency. Should have the same frequency. Okay, number of cycles per second is the frequency. So if you are considering two waves, means both should have the same frequency and it has to maintain same phase. It has to maintain either same phase difference, or zero phase difference. Zero phase difference. So this is one important criteria. So coherent means it had the both the waves should be same frequency, or it has to maintain the same phase difference, or zero phase difference. Okay, so this we have to understand. This is the first point. And the second point is, the sources should be closer to each other. So this is source S1 and this is source S2, right? These sources should be closer to each other. Okay, both should be closer to each other. And then we will observe this pattern or interference pattern on the screen, right? So the next point is, the source and the screen, this is the screen where we are going to observe the interference pattern, are at larger distance. Okay, must be at large distance. Okay, larger distance. So these are the three conditions so that we can get the sustained interference. What is the first condition? I said when two or more waves, if you are considering for interference, means that the waves should be coherent in nature. What is meant by coherent? Same frequency, and then it has to maintain the same phase difference, that is constant phase difference or zero phase difference between the two waves. And then the sources what we are using, both should be closer to each other, and the sources and the screen should be that means must be larger. So these are the conditions we have to maintain to get the sustained interference. Okay, that's all about interference and the conditions to get interference. Okay, so please go through that. If you have any doubt, ask me in the comment box. Thank you everyone.